Magma found simmering under an extinct volcano. Hey race, what that means? St. Anne Lake is nestled in a crater of Romania's Siamadol volcano, which last exploded some 30,000 years ago. Now, lush rolling hills cradle the still waters of Romania's St. Anne Lake, which rests in an ancient crater from the eruption of the Siamadol volcano. The peak last, but as it turns out, the rocks miles below this serene scene may be stewing with a surprising amount of heat. A study recent. To be clear, this does not mean an eruption is necessarily in the volcano's future. But the work calls it. We look preferentially at active volcanoes obviously because they show evidence of real risk, says study author of Université Clermont-Auvergne, France. But we shouldn't forget, by pairing geophysical and geochemical analysis with numerical simulations, the study gives researchers a stunning peek into what may be brewing beneath Siamadol, and it promises to help scientists better understand how similar volcanic systems evolve over time. All of this is great work, says a volcanologist at the who was not involved in the study. But she cautions that it's still not us saying that's what the case is, she says. It's saying, at any given time, at least 20 volcanoes are erupting around the world. But there are many more volcanoes like Siamadol that haven't erupted in the last 10,000 years or so are. However, when it comes to volcanoes, extinct is a very iffy word, she says. Some volcanoes. One sign that a seemingly quiet volcano has the potential for future eruptions is if volumes of molten rock linger below it, and past studies at Siamadol had hinted that might be the case. By studying the weight, yet it was still unclear if the rock was truly molten, and if so, how much magma there might be. To answer these questions, Monnier and his colleagues first turned to rocks from the volcano's past eruptions. As magma sits, for example, a class of minerals known as amphiboles change chemistry depending on the temperature and pressure during crystallization. Searching for these, the team combined this geochemical data with what they knew of the system's dimensions and ran numerical simulations to determine how quickly it might have cooled through time, and to see what the volcanic plumbing could look like today. The team verified this result by crafting a model based on measurements of electrical conductivity for previously erupted rocks at varying temperatures, pressures, and water content. This helped them This second approach gave a similar result, suggesting that the zone beneath the volcano is indeed between 20 and 58% molten. While this is we have no other options to explain the geophysical anomaly, Monnier says. Researchers believe that an eruption is possible if a volcano harbors more than roughly 45% molten rock. Below that, thus, this latest analysis suggests that an eruption may be possible at Siamadol, but that does not mean it's inevitable. Importantly, this study also probes the question of what such systems deep inside Earth actually look like. The traditional trope of a magma chamber is this big, gigantic, menacing-looking, red-hot blob of magma sitting in the crust that's about to erupt and kill us all, Ackerson says. But research increasingly suggests that's likely not the case. Instead, for Siamadol, the researchers believe the molten rock collects in two zones of mush, an upper region between 3 and 11 miles deep and a lower, hotter reservoir starting around 18.5 miles down. Each of these zones. This is a new data point in the story of global magmas, Ackerson says. This is one specific search for location/city.
Raindrops, drop top smoking, no cooking the hot pot. Fucking on your bitch, yeah, that. Looking up, open the park pot.